All right, hi everyone. Thank you for joining today, either live or on the YouTube channel. My name is Michael Lubis. I'm the founder of Praxeal.io, and our session for today is Elixir Phoenix security on deserialization and preventing remote code execution in Elixir and Phoenix. So let's begin. For a bit of background, Praxeal.io, it's an application security platform for Elixir. It replaces security tools like Snyk or reCaptcha and Cloudflare bot defense. So if you're curious about, how does it work? Would it make sense for my company? If you have a Phoenix application that's on the public internet, it probably has something that would be helpful for you. So feel free to book a demo or, connect with me. I'm pretty active in Elixir on like official Elixir Slack, for example. Today is also an exciting day because it's the release of Potion Shop, which is an open source vulnerable Elixir app for security education. So I'll actually link the tweet in chat right now, and I'll also have it up on YouTube, but feel free to take a look and download it on your time. Today, I'm going to be showing you an example. It's not Potion Shop itself, but this vulnerability is in Potion Shop. So watching the session for today will help you when you're trying to find this, in Potion Shop, and then also in your own work, avoiding these security problems as well. The final plug is if this topic is interesting to you, on April 18th, I'm giving a remote training for ElixirConf. So you can sign up. The content will be pretty similar to what you're about to watch today, just about more topics. So let's begin. Remote code execution. We're going to use this term to describe a vulnerability in web applications. And in terms of kind of OWASP style, like cross-site scripting or SQL injection, remote code execution is the worst case scenario. The summary is an attacker is sending an HTTP request to your server. Typically, that should result in some kind of predetermined action taking place, like getting an account or doing a transaction, maybe buying something if it's an online store. But you wouldn't expect that an attacker could, cause like a shell command, something like ls or uname a, if you're in Linux, to happen. And if that is the case, it's very, very bad. Compared to a vulnerability like cross-site request forgery, where there has to be kind of like a user interaction, you have to get the user to click on a malicious link. Remote code execution is really bad because that's not the case. The attacker can just figure out how to exploit the server. No user interaction is needed, and the attacker can basically get like SSH access to the server. The equivalent of like a developer that's SSH'd in, you can pull down the database, you can view private keys or passwords. It's really like the worst case scenario for a type of vulnerability. The most recent example that kind of hit popular culture, this is a great YouTube thumbnail, but it was the log4j vulnerability in, or log4shell. Log4j is the library. For how it actually works, the essential pattern is the attacker is doing a malicious HTTP request to the server. The server, is looking up an LDAP resource. Don't worry too much about this. Essentially, the end result of this is, the attacker is sending input to the server and then getting a shell, meaning they can execute like commands on the server, just like they're SSH'd in. Log4shell was the recent high profile example. So you can Google it and, like news articles will come up. But this type of vulnerability can happen in Elixir. And there was a pretty high profile example, a few years ago, and we're going to walk through that now. But to give you the background on how this works technically in Elixir, there's a really interesting property with anonymous functions. So here I have, two anonymous functions. We just do, if you're not really familiar with the syntax, think of like a function definition with one argument, but we're not even using the input to the function. We're just doing IO puts, which is just like a print statement. And then we're returning a tuple, which is continue and the list here. The reason for this, returning this tuple, you'll see in a second. But the important thing to remember is this function has an arity of 1, meaning it takes 1 argument. And this very similar function, B, has an arity of 2. Now, an interesting property in Elixir is that An anonymous function with an arity of 2 implements the enumerable protocol. And what that means is when you take that function and you input it to an enum function like zip here, you can see you're going to get a protocol undefined error. Enumerable is not implemented for this function, but for anonymous functions with an arity of 2, they are enumerable. So for B, you can see like IO puts hi from B. This probably seems like a random bit of Elixir trivia, but it's really important for the vulnerability we're about to discuss. So the second part of this is relating to the Erlang feature binary to term. So, in Erlang, a binary is sort of like a string. Essentially, you're taking user input here. Like the way you would see this typically used in an application is for serialization. Like if you have a tuple in Elixir and the ordering is preserved, that doesn't really translate well to JSON. You have to create a list and then that gets transformed into like a JSON array. But if you're just trying to communicate between 2 servers, you might think, oh, I can just put the tuple and do binary to term, encode it in like base 64 for sending over HTTP. And I'll use the safe option. So it's, secure. The reason this is a security problem is you can encode functions, which is just like a way to execute code. So the safe option in Erlang binary to term, it doesn't actually mean that the function that gets returned is safe. It just means that you're not going to be able to create atoms in Elixir and Erlang. The reason that's relevant is atoms aren't garbage collected. So it's a denial of service problem where you're creating a bunch of atoms and then that can crash the system. But the more kind of important point really is that somebody sending you like a malicious function could now take over your entire server. So if you're reading an Elixir code base and you see Erlang binary to term, that's very bad. But the good news is for this function to actually get executed, in most cases, you would have to do the dot syntax in Elixir, meaning like you do dot and then a function call, but that doesn't usually happen like in production. What does happen is the user input gets passed to an enum function. So it's kind of like a 2-part problem where first you're doing this insecure Erlang binary to term to create a function, and then it's being executed by an enum. If this doesn't really seem clear right now, don't worry, we'll walk through it. But that's kind of like the setup for what's going on. So these pieces caused a vulnerability in a library called Paginator, which was discovered by Peter from Alphabet Security about in 2020, so a few years ago now. But essentially, the root cause of it was binary to term. So if you're curious, like what does this library do? Imagine you have a very simple application and it prints periodic elements. So we have like hydrogen, helium, and then we have a next. So you've probably seen this with JSON APIs where you have to input this key to get the next 5 elements or something. So I'll show you here. You can see if you do page after equal, and that was the like base 64 encoded string that you just saw, this gives you 5 more elements. And what this, what is this thing? It looks like nonsense. But if you decode it in base 64, and then you do Erlang binary to term, you'll see it's actually a list in Elixir. So the first element is a timestamp and the second element is just an integer. So that's the intended kind of expected input. Like this library expects an Elixir list. It did not expect a malicious function. So this is the payload I'm going to use today. It's kind of a classic example where you open a calculator to show that your remote code execution works. This is going to work on my machine right now because I'm using a Mac. But in the real world, you'd have kind of your web server where it's running like a Linux box, and it would do like what's called a reverse shell to connect back, and that would get you access. But we're just going to use the calculator example to show, hey, the payload, the exploit worked. So this is what it looks like when an attacker inputs a malicious string. It gets parsed by the underlying application, the code gets executed, and a calculator opens. In real, like running on a Linux server, on a cloud system or something, this would give the attacker the ability to, like dump the database, delete users, steal their credentials, take over the server and put it in a botnet. This is like the most severe security incident that you can get kind of in a production server. So the vulnerability report was really well written. It included an example of how to trigger the stack trace, and it kind of got it back to the enum.zip, which we talked about earlier with how those payloads with an arity of 2, when they're anonymous functions, that's why enum.zip is so important in this whole chain of events. So to review kind of what we're talking about, this isn't real Elixir code, but I hope the idea kind of comes in. You have an HTTP request, that's a base64 encoded string. You do Erlang binary to term with the safe option, but that's not really safe. And then if you do an IO inspect, you'd get like a function that was created by an attacker. The problem is you have to execute this function now. And these libraries, they don't usually do like, we expect a list and then we want to execute it. That's not really code that would be written. But what people do expect is to do enum operations on a list. So that's how the vulnerability gets exploited. This is how they fixed it in the library, in the cursor file. There's actually a plug crypto non-executable binary to term. And this library shows up in a lot of like kind of the Elixir standard libraries, obviously plug crypto, very popular in the community. So that kind of concludes the PowerPoint. I'm going to read chat and see if anyone has any questions, but that's just kind of an overview of what we're going to be working on today. So it looks like we don't really have anything. People are still on the call. That's good. I will switch now and kind of walk you through how this works. So you can see here, I have my elements, which is just like a normal Elixir application. I'm going to do mix phx.server. I should make my font a little bigger too, so people can actually read it. So I have mix phx.server here. And then if I do localhost 400, you can see the root page just prints all the elements. So I'm going to show everyone here, kind of walking through this application. So let's start with the router. It's the place to start with Phoenix applications. And you can see that the two scopes we really care about are the kind of root and then page. So if I go to page here, you'll see it prints 5 elements, and then I have the next variable here, which this is a base64 encoding. So then if I go to page controller, you can see it's really just these 3 functions. The first, the index, just lists all the elements and then renders it. The page one is taking the elements and then some metadata, and you see there's an after parameter. So that's kind of like the third one. So we'll skip it for a second here. I just want to show you the second one here, where the elements that get ePage, you can see I'm taking entries and then I have this metadata. So it might not be clear like what this is right now, but I'll show you kind of the elements file and it'll become a little bit clearer. So you can see create element, list element, these are kind of standard. The ones we really care about are from repo Paginator. So you can see we have get ePage and then get ePage with a variable for the after. So what's happening here is Paginate, it's a limit of 5, but then we're also doing for our cursor fields inserted at and ID. So what this means essentially is you're taking some user input and then you're using that to determine like where in the cursor you're going to return it. So we're doing kind of like the next 5, but you could do it in the middle and it could be like a 3 or 2 here. It goes back to that list I showed you earlier. So the kind of expected behavior, I'll go to notes here, or it's the webinar file. I'll kind of show you the expected one. So you can see hydrogen, helium to boron. And then if we go to this page, it switches to like carbon and nitrogen. So it's literally just this like blob of text in the after position there. That's getting parsed by the underlying server. So we discussed this earlier in the PowerPoint, but I just want to show everyone again to kind of really drive the point home. If you have a function with an arity of 2 here for B, the way you would normally execute this, you would do B and then it would be like 1 or 2, and that's how you would execute the function. This pattern doesn't really show up in Phoenix applications that do the binary to term. What does show up is, enum.zip, and then we're passing the anonymous function B, and you can see that results in the code execution. So that's how this vulnerability is going to get exploited. So the way it works is you're just taking like the exploit payload here. So you can see it's system command. This is like an Elixir system, but I'm just doing like open a calculator, like a normal kind of shell command. And then it gets encoded into this, base64 encoded blob. So if I go here, I'm going to click on this link, and this is the equivalent of like an attacker sending this payload to a server. You can see the calculator opened. So that means it worked. But we want to kind of figure out like what's going on. Why is this actually being triggered? So what's kind of a cool thing you can do in Elixir, I'll show you here, is if you want to inspect like what's going on under the hood of the library, you can actually do a path here and then look up the GitHub repos. Yep. Okay. So that can actually show you like the exact code path where this is happening. So the encoded cursor is getting passed down here. This is like the decode. We're just kind of down a few levels. But you can see it's base64 decoding. And then this is the vulnerable code path. So this is how they fixed it, but I'll show you the vulnerable one. They're doing Erlang binary to term safe here. So the decode function is returning our malicious function. However, what happens like after this, we have to get it to do that, to get it to like an enum example. And I'll show you how the person who discovered this vulnerability was able to do that. So we have this running. This is with the vulnerable version. I'm going to go back to the webinar text here. And this is the stack trace example. So you can see if I go back to the terminal, so we can kind of trace what's going on. So we start with our endpoint, and then that's where that's kind of like the entry point to every Phoenix application, where the HTTP request is getting parsed. And then you can see we're in page controller, like we were just in there kind of stepping through the code. And then we go to the Paginator library, and then you can see enum zip reduce. So this is where like the function call that triggered the stack trace is happening. The payload that was used for this, it's right here. So you can see it's just an IO inspect, and this is just like a process info current stack trace. So this tells you, okay, we know the exploit works. Where was it being triggered? Like, why is this enum, or why is this anonymous function being executed? And it's because, it was being sent into an enum. So that kind of concludes like why this was vulnerable. I'm going to read chat, and then we can talk about how you would find this in your own code base. So we have one comment, curious why the fix is, it's about serializing the code.
Oh, that maybe isn't that relevant. I was just curious why they fixed it. They're probably just trying to do a quick fix, but I was curious. It's an interesting choice to serialize Elixir code as a cursor. Like that's an odd choice to begin with. So it's interesting that they kind of rolled with that, given the.
Yeah, that's a good point. Typically, I see like JSON used as like kind of the format for doing this. The thing is, you can do it securely. So like the plug, I'll show the like plug crypto non-executable binary to term. This is how like plug functions. Like, so there is a reason, there's a good reason to be doing like serialization. And you find it in every language. I think more it's just this Erlang binary to term safe. It's a little bit misleading if you're a developer. The non-executable, it's like very explicit, but to like use this effectively, you sort of have to know that this is a problem already, and be familiar with like how this happens, which we just talked about. So the next thing I'm actually really excited to show you is, let's say that you are just dropped into a new project. You're not really familiar with this, but you want to figure out like, okay, is my application vulnerable to this? The first place you might go is Soblo, which is a really good library. It's able to detect if you have this vulnerability in your source code, but I'll show you what happens when you run mix Soblo here. So you'll notice it doesn't detect this problem. And the reason is because it's not a vulnerability in the source code of the elements. Like when I say the elements project, I mean, if I go to mix or if I go to application here, you can see it's like called elements. But then there's sub projects, which in this case is Paginator. So what you actually can do though is do mix depths audit. This is an open source library that checks if your dependencies are vulnerable, and it will tell you like, hey, the Paginator library, it's vulnerable to this. So those are the two commands that I would start if you're doing like a security audit. But there's another one you can do, which is just grep. It's just like normal grep, but you're doing the recursive example here. So I'll show you. If you do grep recursive Erlang binary to term, and we're just going to do our current directory, that's the dot. It's just going through. There's a lot of files, I think, because I pulled in some dependencies, so it can actually take a pretty long while to run this, especially if you have like binary files. Did I enter that correctly? It usually goes. I mean, you can see the issue with this. It takes a while, and then it gives you this output, which is a little bit cryptic. So you have plug crypto. And this is Erlang binary to term. You can see it's defined here. But what you will also notice is like non-executable binary to term. You also see Phoenix Ecto Sandbox uses binary to term. You usually can't get user input to that. And then you have the Paginator library, which is doing the cursor Erlang binary to term safe. So like if you had your own project and let's say there was this vulnerability lurking in like a dependency, so it wasn't in the vulnerability database yet, you can just grep for it. And I've done this on pen tests, so I recommend it. So like with Soblo will give you kind of like a surface level, like, hey, here's what the current code looks like, but you kind of want to go one level deeper and check this in the dependencies. So that's kind of the conclusion for today. I hope this kind of session was, useful for you. If you'd like to learn more, feel free to go to the ElixirConf website. You can sign up for the training. There'll be a lot more content kind of with a similar format, as well as like an interactive lab where you'll be writing this yourself. So I will pause the recording now. Thank you for watching if you're viewing this on the YouTube channel.